This is a really important section. I know it's only this fourth or fifth section of the first chapter, but you'll get a lot of very important vocabulary in this chapter or this section. Okay. So when we talk about angle pairs, we're talking about two angles usually. There could be more though in a couple of these. So the first one we talk about are adjacent angles. What's that word mean to you? Next to each other. Perfect. Okay. So two angles next to each other. So if they're next to each other, what do they share? If angles are next to each other, what do they share? Go ahead, you can think this morning. When we're talking about these, we're not just, they have to be connected. We'll make it simpler and just use numbers, right? So angles 1 and angles 2 are adjacent to each other, so what do they share? Yeah. They have a common vertex and side. Right? So if we actually put letters in here, J-A-Y-S. My side that would be in common would be A-S, right? Okay, so every single time they share those two things, but they don't have anything inside in common. So nothing on the interior of this one would be on the interior of this one. Agreed? Okay, so adjacent. Any questions there? Next one's really important. Linear pair. So this would be one that most of the time we're going to do it as just two angles, but the pair in this situation could be more than two. So you could have multiple, 4 or 5 or 6 of them. But if it's a linear pair, what do you think that means? What's linear mean? It's got to make a line, right? So we're going to say 2 or more angles that make up a line. So we use a linear pair all the time, or a lot. So originally they would say if it's a true linear pair, this would be my linear pair, right? Again, if we just use this. JAS plus SAY would be 180 degrees. Now, some of you might argue, well, JAY isn't a straight line. You just kind of got to go with it. All right? I know I told you at the beginning that you can't really go by the pictures, but for straight lines, you kind of want to. When we say 2 or more angles, though, so I could put something here, and as long as we add more points, we could say all of those angles right there add up to 180 degrees, right? So if we said that this was 50 degrees, this was 35 degrees, and this was 42 degrees, can I find KAP? All I have to do is add up the rest of them and subtract it from 180 degrees, right? Here's something else that I don't know if we talked about. So when I say angle KAP is equal to, anybody do the math? 80, 120, what's 127 minus 180? So 80 minus 27. 33. Okay, so again, doesn't really look like that might be 33 degrees. it doesn't matter. We just do it because we know that it works mathematically. So here's something that I don't think we talked about. Because we're talking about an angle, I need a what here? I need a degree symbol. If you don't want to write the degree symbol, you can write this. But if you're not going to put the degree symbol, you got to have a little m out in front of your angle symbol. Because it's saying the measure of that angle is 33. Okay? Little thing. Now again, can I, up here, naming my angles, can I just say angle A? No, why? Lots of angle A's, right? They're all angle A's in a sense. So in this one, I either have to use the 3 letters or I'd have to use the numbers. Okay? Linear pairs, really important. Always going to add up to what? Right. So make up a line, come back here and say sum of 180 degrees. Next one. Are you okay with that? Sorry. Next one are vertical angles. Any idea what this is? Anybody ever heard of vertical angles? Vertical angles would be made from intersecting lines. If lines intersect, what do? They cross. So draw intersecting lines. Doesn't matter how you draw them. Sorry. And then we're gonna name them by letters, or sorry, by numbers. 1, 2, 3, and 4. So anytime that you have lines that cross, you're going to form vertical angles. These are going to be 2 non-adjacent. So what don't they do to each other? They don't touch, right? They're not right next to each other. So 2 non-adjacent angles, or I would say basically that are across from each other. So if this is true, if they're across from each other, what groups of angles would you say this is true of? 2 and 4. Angle 2, angle 4. Everybody okay with that? So what's my other set? Or angle 1 and angle 3. Now, what's important about this? Each set of vertical angles, I'm really lazy, so I write VA, this is what's important about them, congruent to each other. So I come back over here and I put a congruent symbol in between. Angle 2 is congruent to angle 4, angle 1 is congruent to angle 3. So anytime that you have intersecting lines from here on out, this will occur. And they are congruent to each other. Okay? Any confusion so far? Now we can actually think a little bit. I know, it's a Tuesday. Next one are supplementary angles. This you probably have heard of, right? This word? What do supplementary angles mean? Thank you very much. 2 or more, and again, we could say more because we could have, just like we had over here with the one that I erased, but mainly it's 2 that add up up to 180 degrees. So here's a question. Don't say anything out loud, just let everybody think. Are all supplementary angles linear pairs? Or are all linear pairs supplementary angles? So we already erased linear pairs. But are linear pairs supplementary angles, or supplementary angles linear pairs? What? Say it louder. Say it louder.
Or linear pairs or supplementary angles?
Why?
Because they equal 180.
Because they equal 180. So why are supplementary angles, or sorry, are linear pairs always, sorry, are supplementary pairs always a linear pair?
No, you give it 2 or more.
Okay. Take out the more part then. If I have 2 angles, and I tell you that they're supplementary, are they always a linear pair?
Yes.
Can? I'm going to go with Con. Why do you say no, Con?
Because there might not always be a straight line.
Oh. Exactly right. Okay? So, linear pairs are supplementary. Because why? Lauren?
Equal 180.
Yeah. Because equal 180 degrees. Not all supplementary angles form linear pairs. Because why, Kyle? It's not always a straight line. So give me an example of supplementary angles that aren't a linear pair. Let's just say that I have an angle of 87 degrees. What's my other angle that would make what is 87's supplement? So when we say the word supplement, we're saying what adds up with 87 to make 180? We would say what? 93? So those two are supplements of each other. And an example of this one right here, where there's supplementary angles but they're not linear pairs, would be what Con said. Here's my 87 degrees. Well, that was ugly one. Right? That angle right there and that angle right there are supplements or supplementary to each other, but they definitely don't make a linear pair. But I could cut that angle out, turn it around and stick it right here, and then I'd have my straight line. Make sense? Okay? So again, really important concept that we have. So what's kind of opposite of supplementary? What's the other word? Yeah, there you go. Complement. And what are complementary angles? Add up to 90. Awesome. 2 angles whose sum is 90 degrees. Now again, we could throw in that word or more because we could have multiples. And then these angles would be complements of each other. But again, how do I know that I have a 90-degree angle? I gotta have my box, right? So, I have no idea if that's a 90-degree angle, but when I put that in there, then I'm telling you it's a 90-degree angle. and then I draw something here, and I put that this is 37 degrees. So what is its complement then? How much is it? 50/30. So again, these two are complements of each other. So they'll give you a number, and they'll say, what is its complement? And then you just have to subtract it from 90 degrees, or do it multiple ways. Obviously, then I can do this with algebra problems also. Okay. So if I look at this problem right up here, the measure of angle N is 8x minus 6, and the measure of angle M is 14x plus 8. It says find its complement. So what would I do? If they say complement, I automatically know that they have a sum of what? 90 degrees, right? So 8x minus 6 plus 14x plus 8 equals 90. Again, now this is where you would have to read the directions. Okay? It says angle N is a complement of angle M. It tells you that in the directions. So I automatically, anytime I hear complement, I just know that it's got to be equal to 90 degrees. And then I do the math. 8x and 14x. Negative 6 plus 8. Subtract 2 from both sides. Divide by 22 from both sides. And last but not least, this is what a lot of you didn't do on the quiz. Answer the question for what it says. Find x. Yes, you did that. And the measure of angle M. Now, just because these are complementary to each other, are they always 45 and 45? Heck no. That's where some people just fall into the trap. They're thinking, well, I hear the word complement, I heard 90 degrees. They always have to be halves. They don't have to be halvesies. Okay? So what do we get for M? Which one was M? 8x or the 14x? 14x. So we're putting 4 into this quantity right here. What's 14 times 4? 56 plus 8. 64 degrees, right? Angle M equals. Or we can write the measure of angle M. Both are acceptable. Okay? Questions there? Last one for today, anyway. Then we'll look at some examples. Perpendicular lines. What are perpendicular lines? Two lines that intersect. So what do they do to each other? If they intersect, they cross, right? They cross to form 4 right angles. So how do I show this to everybody that when I draw that figure right there that they form 90-degree angles? I got to have a what in there? A box. Do I have to write 4 boxes? No, because if this is 90 degrees, the one that's across from it has to be 90 degrees because why? What did we call it today? Vertical angles. These are vertical, so this has to have a box. And then these two, up and down or left and right, would form what? A linear pair. So we said at the beginning that a linear pair had to equal 180 degrees. So if this is 90, this one also has to be 90. Okay. What's the symbol for perpendicular? Yep. Shown by an upside down T. So if we came back here and said that this was M and this was N, I would say line M is perpendicular to line N. So a lot of vocabulary, right? Most important thing from here on out is that when you're looking at problems and they confuse you, draw pictures. If the picture is given to you or the diagram is given to you, realize that it's not always drawn to perfection. That most of the time, if it's obtuse, they'll at least show you that it's greater than 90 degrees. But even sometimes they won't even do that. So don't get frustrated if they give you an angle like this, and I know that that has to be an acute angle, but you find out that it's 110 degrees. I know it's frustrating, but the book's not always great in that aspect. Okay? Questions there? All right, so let's look at some examples. Any questions with any of the things that we looked at today? And let's look at some examples up here. Name an angle pair that satisfies the condition. Two angles that form a linear pair. What two angles form a linear pair in this figure? Two angles that form a linear pair. Come on, don't be shy. Go ahead, Spangler. You look like you want to say something.
TQ and PS.
What does linear pair mean? They got to equal 180. So what are two angles that are next to each other that form a line?
PQRS.
Say it one more time.
PQ and RS.
PQ and RS. What do you think? Her two do that? First off, if I'm going to name these angles, I got to use how many letters? 3. So, first off, find a straight line. Here's a straight line right here. So if I say PIQ, what's the other angle that makes this a straight line? QIS. Right? PIQ and QIS. Or I could have said, they said just two angles, but if we went 3, then we could say PIQ, QIR, and RIS. Make up a linear pair. That makes sense? What's another one then? Say it again. UIT and what? TIR. Okay? It's got to be the whole straight line. The whole straight line. Everybody okay with that? So, give me vertical angles in this one. One set of vertical angles. Come on. QIT. But QIT would be a straight line. Remember, what are my vertical angles? We're talking about angles, not lines here. So if I pick an angle, here's my angle. PIQ is an angle. This is an angle. TIS would be vertical to it. If I said UIT, what is vertical to that angle? QIR. And what's true about this angle and this angle? They're the same because they're congruent. Because they are vertical lines, or vertical angles, sorry, not vertical lines. Okay? Maybe it's easier with this one. So, name two adjacent angles whose sum is less than 90 degrees. And again, they might look like they're 90 degrees, but do I have any 90-degree angles in this? Not at all. Even if I take the numbers and add them up, none of them add up to 90 degrees that I could make a box. So give me two angles that are adjacent to each other. What does that mean? They're right next to each other. They share a side. So what two angles share a side but are less than 90 degrees? Con? NAF and BAF. But if I use BAF like you said, look how big that one is.
E.
Oh, you said E? Yeah, perfect. EAF. These two right down here, right? Sorry, misheard you.
That'd be the same as BAC and BAC.
So those two and those two would be less than 90 degrees, right? And they're right next to each other. So they're adjacent. Everybody agree? Okay. Let's do one here. Name a linear pair. Two angles or three angles that would make up a linear pair. What would you say? So now if I'm looking at a linear pair, I'm looking at some straight line, right? What angles make up that yellow line? Say it louder. No, that make up this one. So this one, BAE would cross that yellow line, but I want these three angles right here would make up that yellow line. So what are those three angles that I just swiped across? You guys are, you can make a mistake. You can be loud and make a mistake. DAC. What else? Keep going. BAC. Perfect. One more. Now this one way over here. Perfect. Awesome. Everybody hear what he said? DAC, CAB, and BAN would make a linear pair, right? They would make that yellow line. Perfect. Sorry, problem. Find the measure of two supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other angle. Holy cow, right? Now we got to think a little bit. Find the measure of two supplementary angles. So first off, what's that mean to you? If they tell me it's two supplementary angles, they have to what? So they're going to equal 180 degrees. Okay? If the measure of one angle is 6 less than 5 times the measure of the other one. So how do I show that I'm going to add up two angles together?
Janice taking out of her seat or what? She was all nervous. She was like looking at you. Can you help Mrs. Dreckman out between 7th and 8th today? Just have her kids.
No, actually.
It's fine.
I'll tell you why later.
All right.
Between 7th and 8th?
Yeah. Don't worry about it. I know, I got another solution.
So find the measures of two supplementary angles if the measure of one angle is 6 less than 5 times their measure. So how do I show this in the first place? How do I show when I don't know two things? I would say basically x plus y, right? That's one, and then the y is the other. But can I have two different variables in a problem? No. So instead of using y, I have to manipulate another x with the information that they gave me. So how do I say one angle is 6 less than 5 times the other one? How do you write that as a quantity? 5x. Remember, when we use less than, we have to flip-flop them. Minus 6. But I'm going to take x plus this whole quantity, and that's my other angle in the problem. Okay, so then I would figure out one angle, find out what my x is, and I can figure out the other one. So what is my x? X plus 5x is 6x, right? I add 6 to this side, so I get 186. So what's x? How much? 31. How do I find my other angle?
Look at that.
Put it into that quantity right there and figure out what x is. So 31 times 5 is 155 minus 6. 149. Is 149 plus 31 180? Yeah, so it works, right? So you're going to have to think a little bit. And that's what scares a lot of you, that you don't like to think. Because I know, and again, you're going to be wrong sometimes. But you got to concentrate and just take your time and look at the picture. Get all of those vocabulary words out in front of you so you can see them as you're doing them. So, we're going to run out of time here again. Take a picture of it. Again, if you need help, you need to come in and see me. Don't use the excuse that you don't have time.